Welcome to the DIY Honda Garage channel. The DTC P0192 pertains to a low voltage condition detected in the fuel rail pressure sensor circuit of the Honda Civic models from 2016 to 2021. The fuel rail pressure sensor is responsible for monitoring the pressure within the fuel rail, ensuring that the engine receives the optimal amount of fuel for combustion. This sensor is critical for the proper functioning of the engine management system, contributing to fuel efficiency and performance. Its location is typically along the fuel rail, which feeds fuel directly to the engine's injectors. The OBD-II system uses this sensor to maintain appropriate fuel pressure. Thus, any issues can lead to suboptimal performance. The DTC P0192 indicates that the system has detected voltage levels lower than expected, below the allowable threshold, which triggers the diagnostic trouble code. Understanding this code is fundamental for accurately diagnosing and resolving potential issues within the fuel delivery system. The fuel rail pressure sensor plays a pivotal role in regulating engine performance, directly influencing fuel injection efficiency. Located on the fuel rail, which runs along the top of the engine, it measures the pressure of fuel supplied to the engine. This sensor communicates with the Powertrain Control Module, PCM, to adjust fuel delivery based on real-time pressure readings. If the voltage from this sensor drops below the specified threshold of 0.31 volts, the PCM cannot accurately assess the fuel pressure, resulting in the P0192 code being triggered. Problems in this sensor not only affect engine performance, but can also lead to increased fuel consumption and higher emissions. Monitoring the performance of this sensor is crucial, as it ensures that the engine runs smoothly and efficiently under various load conditions. Several issues could cause the DTC P0192 to appear. A faulty fuel rail pressure sensor is one potential cause, as it may fail to provide accurate readings due to internal problems. Additionally, a short in the PF wire, which connects the sensor to the PCM, can also be a culprit, leading to incorrect voltage readings in the sensor circuit. Wiring faults, particularly an open VCC1 line, may prevent correct voltage from reaching the sensor, contributing to low reading conditions. Furthermore, poor connections or loose terminals can also lead to intermittent circuit failures, resulting in the code being triggered. Each of these issues must be systematically evaluated to determine the exact cause of the DTC and to ensure effective resolutions. When DTC P0192 is triggered, there are several symptoms that may be experienced by the driver and can indicate deeper issues within the vehicle's fuel system. Engine performance issues are commonly noted, such as rough idling, stalling, or hesitation during acceleration. This can occur because the engine is receiving incorrect fuel pressure information, leading to suboptimal fuel-air mixture. Additionally, the check engine light, CEL, will typically illuminate on the dashboard, alerting the driver to a potential issue that requires attention. Fuel efficiency problems might also arise, as improper fuel pressure can lead to increased fuel consumption. In severe cases, the engine may enter limp mode, reducing power to prevent further damage. Recognizing these symptoms early can play a critical role in preventing more extensive repairs later. The first step in troubleshooting DTC P0192 is to turn the vehicle to the on mode without starting the engine and wait for a period of 2 seconds. This initial status assessment allows the onboard systems to power up, preparing for diagnostic checks. Following this, the Honda Diagnostic System, HDS, must be utilized to check specific engine parameters, particularly the voltage reading from the fuel rail pressure sensor. The expected threshold value for the fuel pressure signal should be greater than 0.31 volts. If the current conditions indicate a value beneath this threshold, the fault can often be reliably considered duplicated, advising the technician to proceed with further diagnostic steps. However, if readings appear normal, it suggests an intermittent failure, prompting checks for wiring conditions such as loose or corroded connections. In this step, you begin by turning the vehicle to the off-lock mode, as it's crucial to safely handle electrical components. Disconnect the fuel rail pressure sensor's 3P connector before reintroducing power by turning the vehicle to the on mode once again. This disconnection allows for independent measurement of the sensor circuit without interference. The HDS should again be utilized to check the fuel pressure signal. If the voltage reading remains under 0.31 volts, it indicates continuity issues within the circuit, urging the technician to proceed to the next steps. Conversely, if readings exceed the threshold, it suggests a problem localized primarily within the fuel rail pressure sensor itself, advising replacement or further diagnostics specific to that sensor area. Before performing this test, confirm that the vehicle is in the off-lock mode to ensure electrical safety. The next action involves jumping the SCS line with the HDS, which will enter a special diagnostic mode, allowing for further checks. Following this, disconnect the PCM connector E, ADP, to prevent erroneous signals from affecting the readings. Continuity testing between specific test points is crucial. You will check the connection between the fuel rail pressure sensor number 1 and body ground. It's essential that no short circuits exist in this line. If continuity exists, it indicates wiring issues, warranting repair of the short circuit in the PF wire. In case continuity checks show no faults, it implies that the wiring is intact, indicating that you need to explore other possible issues within the PCM or related components. Continuing in the troubleshooting process, measure the voltage between two specified test points while ensuring the vehicle is in the on mode and the fuel rail pressure sensor connector is still disconnected. Particularly, you will check the voltage between the fuel rail pressure sensor connector number 2 and number 3. The expectation is to find a reading close to 5.0 volts, as this is the operational baseline for the sensor to function correctly. If the measurement meets this requirement, it confirms the sensor's operational viability. If the voltage reading is significantly less than 5.0 volts, this is an indicative sign that the fuel rail pressure sensor is faulty, thus necessitating its replacement. Taking these measurements accurately is essential for the integrity of your diagnosis. The final step in this troubleshooting sequence again requires the vehicle to be in an off-lock mode before proceeding with continuity checks. As with previous steps, jump the SCS line with the HDS to set the system into the necessary diagnostic mode, and then disconnect the PCM connector E ADP. The focus will be to test the continuity between the fuel rail pressure sensor connector number 3 and the PCM connector E number 70. Achieving continuity confirms the integrity of the VCC1 wire connecting the PCM to the sensor. Should continuity exist, this indicates the VCC1 wire is functioning correctly, which may guide towards substitutions of PCM for further diagnostics. Conversely, if continuity fails, this suggests a break in the line, necessitating the repair of the open VCC1 wire to resolve the low voltage issue linked to the DTC P0192. Upon completing the required repairs, it's crucial to reconnect all disconnected components thoroughly. Ensuring all sensors, wires, and connectors are securely fastened is essential. Once all connections are reinstated, clear any stored DTCs within the vehicle's PCM or diagnostic system. This will reset the monitoring systems and allow you to observe if the trouble code reappears. Following this, a road test should be conducted to ensure that the vehicle operates without issues, particularly focusing on the engine performance and the fuel delivery. Monitoring the system during the road test provides real-time insights into whether the repairs have successfully resolved the low voltage condition associated with DTC P0192. This stage of confirming all systems function optimally is vital for restoring the Honda Civic's reliable performance. Preventive maintenance is essential to mitigate the risks of recurring issues with DTC P0192. Regular inspections of the wiring harnesses leading to the fuel rail pressure sensor ensure that any signs of wear, damage, or corrosion are identified early. In addition, periodic checks of connector security and integrity can help prevent intermittent faults due to loose connections. Evaluating the performance of the entire fuel system, including regular inspections of the fuel rail and injectors, allows for early detection of pressure irregularities. Moreover, ensuring that only quality fuel is used can prevent contamination issues that may impair sensor functionality. Keeping these practices in mind will significantly improve the longevity and reliability of the fuel system in Honda Civic models, thus maintaining engine performance over time. In summary, understanding DTC P0192 and its implications for the fuel rail pressure sensor is critical for maintaining optimal engine performance in Honda Civic models from 2016 to 2021. Following the systematic troubleshooting steps outlined will facilitate accurate diagnosis and effective repair, ensuring safe and reliable vehicle operation. Critical components, such as the wiring, PCM, and the fuel pressure sensor itself, warrant careful examination to identify root causes of low voltage conditions. Through diligent diagnostic practices and adherence to preventive maintenance schedules, the likelihood of facing similar issues in the future can be considerably diminished. Ultimately, maintaining the health of the fuel system will contribute to overall vehicle performance, driver satisfaction, and longevity of the Honda Civic. Please like and subscribe to the channel. See you next time.